Hello everyone, myself Ushasri from CSE Cyber Physical Systems Department. Today I would like to discuss about the topic synchronous motor. What are these electrical motors? They are electromechanical devices that convert electrical energy to mechanical energy. Based on that, they are classified into two types, that is single phase and three phase motors. The most common types of three phase motors are synchronous and induction motors. What is synchronous motors? It is an AC electric motor in which, at steady state, the rotation of the shaft is synchronized with the frequency of the supply current, and the rotation period is exactly equal to the integral number of AC cycles. Now let's look into the construction of this motor. The structure is same as the other motors. Well, the main components of these motors are stator, rotor, exciter, and frame. Stator and rotor are the main parts of the synchronous motor. Well, both stator and rotor make up the electric and magnetic circuitry of the synchronous motor. Stator. Stator is a stationary part of this motor. It is constructed with thin silicon lamination and insulated by a surface coating, that is to minimize the eddy current. The winding circuit of the stator is called stator winding. It is supplied three-phase AC power. And next is rotor. Rotor is the rotating part of the that rotates exactly at the same speed as the stator magnetic field. It is excited by DC source. It consists of poles which depends on speed and frequency of the machine. There are two types of rotor constructions in this motor, that are salient pole rotors and non-salient pole rotors. These are salient pole rotors, the poles extended beyond from the rotor surface, and this is non-salient pole rotor that while winding are placed in the slot machinery mission rotors. And the third most important component is exciter. It is a small generator placed in the rotor which provides power for the excitation. And next is frame. It actually protects the motor and covers the whole assembly. Now let's discuss about the working principle of the synchronous motor. The operation of a synchronous motor is that a rotor follows the rotating magnetic field of a stator and rotates at the speed approaching it. The rotor winding is excited by DC source while stator winding is excited by AC source. Due to the three-phase AC, a three-phase rotating magnetic field is produced by stator winding. While it comes to rotor winding provides a constant magnetic field. At some rotations, the poles of two magnetic fields attract each other and sometimes they repel each other. The rotor will not start to rotate due to its inertia. There is an external source which provides initial rotation. Once the rotor starts moving at the synchronous speed, the external source will automatically shut it down. Let's see the types of synchronous motor. The synchronous motor can be classified into two different types based on how the rotor is magnetized. Non-excited synchronous motor and DC excited synchronous motor. Non-excited synchronous motor where the rotor is made up of steel. At synchronous speed, it rotates with the rotating magnetic field of a stator. So it has the almost constant magnetic field through it. Non-excited synchronous motor are available in three designs: hysteresis synchronous motor, reluctant synchronous motor, permanent magnet synchronous motor. Hysteresis synchronous motor are single phase motors where the rotor is made up of ferromagnetic material. They are self-starting and do not need any additional winding. Next is reluctant synchronous motor. Is always Reluctance is always minimum when a piece of iron rotates to complete a magnetic flux path. The reluctance increases with the angle between them when the poles are aligned with the magnetic field of the stator. This will actually create a torque pulling the rotor alignment into the pole near the stator field. Next is permanent magnet synchronous motor. These uses permanent magnets in the steel rotor to create a constant magnetic flux. And last is direct current excited synchronous motor. These motors actually require a DC supply to the rotor to generate a magnetic field. It has both stator winding as well as rotor winding. The direct current can be supplied from a separate DC source or from a DC generator which is connected to the motor. Hence, today we discussed about the construction of synchronous motor, working principle and the types of synchronous motor. And that's it for today. Thank you.